Hey guys, Tim for MVP Machine. Today I'm going to be showing you how I square this relatively ugly block of steel. It's approximately 4.5 by 3.5 by about 2 3/4 tall, and it has bandsaw cuts on 4 surfaces, shown with an X, and then 2 surfaces that are basically mill finish, or how it came from the steel supplier. And this came off of our scrap rack. It was obviously cut off a larger chunk, but what we need to do is a 6-side square on this, so that we can use it for something else. And I'm going to take it over to the machine and I'll show you how we do that. Okay, I've determined with the machinist square that and I'm going off of I'm going to call it the factory edge, which is down here, and this is the other one. And I push the machinist square against the factory edge, and I'm out by about a 30-second up at the top here. So this basically is cut, on an angle like that. This cut on this side, we're going to do it like this, is very good. And the other saw cut side is also very square. So rather than square this like I normally would, I would start out like this. I'm actually going to do this long ways like this, because those are relatively square saw cuts, and I'm going to establish a reference surface first with this, and I'm going to set this up in the vise and we'll go from there. Okay, I've got it set up in the vise. I'm actually set up on parallels, and the reason on the first squaring operation, most of the time you don't really have to worry about having parallels under there. They're kind of meaningless, but being that we have bottom factory edge and this side, I'm using the bottom edge, and I'm using these 1/4 inch parallels, and with it tightened in the vise, and I hit it down a couple of times with a mallet, I'm actually sitting nice and square on the parallel. So I'm going to take advantage of that on the first operation, and I'm going to cut this surface, and we'll bring that relatively square to the bottom surface, and I'll show you where we go from there. Okay, as my squaring tool, I'm going to be using the Suburban Tool fly cutter with a 7-inch bar. And I first need to establish, since we know this surface is not square at all, I need to establish where the tool is. So I've jogged it down to where the insert does not hit the part when I swing it over it. I'm right above the high spots, so now I'm going to put on the spindle at 750 RPMs. And I'm going to jog down 1/1000th of an inch at a time until I hear it hit, which is right there. I'm going to stop the spindle. I'm going to back off of the part, and then we're going to jog down. We're going to go 15/1000ths of an inch cuts, and it's going to take a few to clean this one up. And we'll take our first cut. Okay, now we'll go down another 15. Oh, didn't get quite off the part. Oops. The spinning diameter of this tool can be deceiving. So now we'll go down another 15. take that cut. And then we'll go down another 15. Still not quite there yet, obviously. So we'll go down another 15. And I could be taking 20 thou cuts with this as well. You don't want to exceed much past that on the fly cutter on field. Okay, it looks like we've got a full cleanup there. And that's all we're going for on this. The finish is real nice, but we're squaring this block. It's going to be used for another purpose or another operation, so that finish is more than adequate. Now what I'll do is I'm going to deburr these edges off camera, and we'll set it up on the next operation, which is going to be this facing the back jaw. And we'll take our next cut. Okay, it's set up in the vise again. I have the cut face that we just cut along the back solid jaw. It does tap down on the parallels, and the parallels are in there, they're not moving. Now that doesn't really tell us that this is square. What's important is that this back surface that we just cut is up and down straight, and we can't rely, even though it's a factory mill edge that's down on the parallels, we can't rely on that being square because we still have not cut this bottom edge, and we have not cut this other factory edge either. So the only way to really check that, if this is a precision piece, we know that we're relatively square because it's down on the parallels, but we can check it with an indicator. So we're going to do that just to make sure that it's perfectly square. So I'll put an indicator to show you. Okay, I've got my 1/1000th of an inch indicator in there, and we're going to run it along the back of this part to see how good we are up and down. And I usually like to start towards the bottom of the part so I don't have to push the needle downwards. And we'll just jog in here, touch. Set it to 0 and see how good we are up and down. Zoom in a little bit so you can see that. And that's pretty much dead nuts right there. So now we're going to cut this face and we'll have 2 square surfaces established. Okay, now I have the fly cutter set up above the part. Again, we're going to have to touch off because we don't know how much of an angle this surface is on. So we'll start up the spindle, jog down, touch the part, then move off the part, go down 15 thou, and take our cut. going to go 20 thou on this cut. And 15 should clear this the rest of the way up. Yeah, not quite. We'll try 10 more. Okay, now I'm going to deburr the edges, and the next operation will have this surface against the back jaw and the back surface against the parallels. So we'll get that set up and go from there. Okay, it's going to go in there. Let me zoom out a little bit. It's going to go in there with this against the back, and the first surface that we cut will be against the bottom, so just like this. Okay, now we're set up on the third cut. We're going to basically repeat the process, touch off the top, and take the cut until it cleans up. We know that these were the factory edges, so they're going to just probably take one cut each. So we'll move along pretty quickly from here. That cleaned up in one cut. I'll deburr those corners and we'll get set up on the next cut. Okay, we're on our fourth side. We're going to do the same process, touch off the tool. And 10 thou should clean this up. This is the second factory side, or actually one of the 4 factory sides, but no, the second factory side. Okay, that one cleaned up with just 10 thou. So now we've got a 4-side square, and I'll show you how we accomplish squaring the ends now, the 2 ends. Just wanted to show you guys real quick. I use these 1/4-inch thick parallels. I like them a lot better than the typical 1/8-inch parallels. But what's nice about these, and you can see them with the 1/8-inch too, but if you have a little piece of dirt under these, they'll pretty much stand off the the back of the vise, even when you push it up against it, so you can tell that you don't have your vise quite clean. And when you're squaring, actually doing anything, your vise has to be perfectly clean. So, alright, I'll show you how we do these other two sides, or ends I should say. Okay, I have the part set back up in the vise. What you can do, if you don't know how good your ends are, which we don't, these we know we used in the first operation to cut, so they're fairly decent. You can use a square, and that'll get you close, and they didn't even do that. I'm going to basically check it with the indicator, and we've got our indicator set up right here. We'll draw it down, we'll touch it. Now I'm going to drag it up, and we'll see how square we are. Okay, we're shy about 5/1000ths of an inch up at the top. So now all I have to do, this is going to be difficult to show you with the camera in my hand, but I'll do my best. Is just tap this in. I've got hammer, and I'm going to tap it until I hit 0. We're 0, and let's check it again. And now we're straight up and down. So now we're going to cut this space, and we'll go from there. Okay, we're basically just going to repeat the same process that we did on the other 4 surfaces that we've cut already. Some of you may have noticed that I'm cutting in a direction that if we're putting a lot of pressure on this part, it could shove it out the side of the vise. It's one of the reasons I like using a fly cutter. It puts very little tool pressure on the part, so there's very little risk. But if you're, and I also have a Kurt vise that has 7,300 pounds of holding force, and I've got it cranked pretty good on, especially on this operation where it has a little bit of leverage being up out of the vise due to the height of the part. But if you had any less of a vise, or if you're using a tool that exerts more pressure on the part, you definitely want to cut from the side and put your pressure up against the back jaw. So here we go. I'm going to establish the top of that, which is right there. And then we'll take our 15 cal cut. Another, let's say 12 thou. Okay, we've got the 5th side cut. Let me deburr those edges, and I'll show you the last cut. Okay, now we're going to do the final cut on the 6th side, basically the same as the other ones. I did check to make sure, since I'm just using the the bottom of the vise, and we are straight up and down on the sides. So I did that off camera, and here we go on this last side. We'll touch off the top. And we're going to take 10 thou and see how that does. Okay, that's a nice cleanup with a 10 thou pass. I'm going to take this out, deburr that, and I'll give you some final thoughts. I just realized that this block that I squared, I assumed that it was some sort of a hot rolled steel, but turns out it's P20 mold steel, and I had a couple of clues after cutting it. One is the finish is a little bit strange. It has kind of like a little bit of an orange peel to it, and which is kind of common when you fly cut P20. And then the other was the chips that I was throwing are blue, and that tells me that it's a harder steel. P20 typically, when you machine it, it's 30 Rockwell, which is kind of hard. So just an interesting side note. It actually came from a part that I did probably about 11 years ago. It was a big clevis, and it was one of the first times I used the 11-inch fly cutter bar. I'll pull up a picture on the computer and I'll show it to you guys. Okay, this is the part that I made, and it was approximately 17.5 inches, 18 inches long, and about 3.5 inches thick. And what was challenging about this part was it has this 6-inch slot that goes all the way through it, 6 inches long. I think it was a little bit over 6 inches long, and that had to be held widthwise to within 1/1000th of an inch. And this material is real good. It will not open up when you remove a big chunk like that, but it's a very expensive piece of material. And what we just squared was probably the drop that came out of this area here that was originally 3.5 inch or 3 3/4 inch by 20 inch long by probably 14 inch tall plate. And first time I used the 11-inch fly cutter bar from Suburban Tool was to finish the inside of this. I had the part laid flat, and this isn't drawn to size. This is the 11-inch bar right here, but it's not. This is not blown up to size. It would have taken up approximately that much of this bar, and basically just did top and bottom with that mounted to the table all in one operation. So I was pretty happy with myself when I didn't scrap that piece of P20 mold steel. Okay, we're back over to the part that we just squared, and a couple of thoughts I had after doing this. I was lucky in that I was able to get it to sit flat on the parallels in every operation, and a lot of people will use like a welding rod, stick it in front of the part up against the front jaw in case they won't knock down on the parallels if it won't sit flat. I don't like to do that. If I can't get it to sit flat, I will usually use a piece of emery. I'll just tear off a 6-inch piece or so of emery cloth, and I will put it in front of the part right over the parallel, and that gives you some adjustment to bang it down on top of the parallel so it'll sit flat. If that doesn't work, if that thickness doesn't work, you can fold the emery in half and put it like that above your parallel. That gives you even more adjustment, and 9 times out of 10 you can get just about anything to knock down on the parallel. So the other thing we didn't talk about, we just squared this part. We didn't have to bring it to any specific size, but if we did, basically you would just take the stock off of 2 sides, and then the other 2 sides you'd either use a face mill if you had to take a lot of stock off, or you could use a fly cutter and just light passes to bring it into size, and then the stock would come off the other 2 sides where you have already established this back and bottom face, so that you know that you're cutting square. The tool that we use is a Suburban Tool fly cutter with a 7.5 inch bar, and that's available from subtool.com and also on eBay. There'll be a link below in the description, and please feel free to comment. I'm sure there's people that square a lot differently than I do, and basically, in my opinion, it's common sense to look at your part first that you're trying to square, and adjust it accordingly, and but there's all kinds of different ways to do that. So thank you for watching, and we'll see you in the next video.